All right, so in this video, we're just going to do the last part of G1, which is the law of syllogism, law of detachment, law of contrapositive, and how we can come up with some counterexamples. So if I were to look at these statements, this is a review of each of those. So the first one says, if Caleb studies, then he will pass the test. Then it says, Caleb did not pass the test. So what's important to notice here is that this says a P to Q statement. So if I look here, what happened was it switched and it made Q come first with the not. So it said Caleb did not pass the test. So what I can actually say here is Caleb did not study. So this is the law of contrapositive that says if you have a conditional statement, then the contrapositive is also going to be a valid statement. So if Caleb studies, then he will pass the test. So if Caleb does not pass the test, he did not study. That's your law of contrapositive. The next one says, if you fall in the mud, then you will get dirty. Well, Jane fell in the mud. So we have this generic statement here that says you will fall in the mud, then you will get dirty. And then we actually see the hypothesis is true. So when we have a true hypothesis, it means that we are also going to have the conclusion be true. So if Jane fell in the mud, then Jane got dirty. And so what we'll say, that one is our law of detachment. So it's if you know a conditional statement and the hypothesis is true, then the conclusion must also be true. The last one says, if Joseph gets a job, then he will make money. If Joseph makes money, then he will save for a car. So if I go ahead and I cross the middleman out, notice we had the repeat of he will make money, he makes money. We're going to just have the hypothesis from the original statement with the conclusion from the second statement to make a new conditional statement. So if Joseph gets a job, then he can save for a car. Oops. So that is our last one, which is actually the law of syllogism. Now, just quickly, what I want to show you is the law of syllogism when you write it out in symbolic notation. We would say Joseph gets a car, so we could say that's our PQ statement. And then notice the Q repeats. So Q, and we would say R. And so our final statement here would actually be R, therefore, P to R. That's what it looks like in symbolic notation. All right. Up here, if I said P, arrow Q for our original, and then we were told not Q, so what we're allowed to assume here is R, therefore, not P. That's what the law of contrapositive looks like. All right. And then our law of detachment in symbolic notation would actually say that we would have if you fall in the mud, you will get dirty. That's our P to Q. And then we were told that P, and so what we are assuming here is therefore Q. Right. So the last thing I want to cover in this video is if a number is odd, then it has to be prime. So for odd numbers, when we think about odd numbers, you would have a 1, 3, 5, 7, 9, 11. So when we think about a counterexample, it has to have a true hypothesis. So then we think about what it means to be prime. So for a number to be prime, it means that the only factors it has are 1 and itself. So the factors of 1 and itself, so 1 and 1, that's prime, that works. 3 only has 3 and 1, that's also prime. 5 has 5 and 1, no other factors, so that's true. And so does 7. So up until I get to 7, this statement actually looks like it's true. But then when I get to 9, 9 has 1 and 9, but it also has 3 and 3. So 9 is odd, but not prime. So that is one example of what a counterexample could have been. When you need to give a counterexample, you only give one, even though there's multiple different correct answers. So 11 makes my statement true, 13 makes my statement true, but 15 would have been another good counterexample. And that's how we do counterexamples.